Next, we have logistical growth model. Now, we talked about exponential growth models. According to exponential growth model, we say that as the time increases, the population keeps on increasing. But that is not logistic, right? That doesn't make sense in the real life words. In the real life words, the resources are limited. So population or culture doesn't keep on growing unlimited. So logistic growth model is a function which written as this function y is equal to c divided by 1 plus a times e raised to the power negative dt. It says there is an exponential growth, but after a certain time it starts to stagnate because we have limited resources. It starts to stagnate and it keeps on stabilized till one limit. Okay, so here in this function a, b and c are some positive constants. It says that rate of change is increasing, but there is a point of inflection. After that it stops increasing that fast. It stagnates. So let's take another example of population of California, similar function which we did before, but now we are taking a logistic model. We are saying it cannot keep on increasing over time. Can be approximated by logistic growth model function where t is time in years since year 2000. Determine the population in year 2000. Okay, in 2000 t would be 0 because t is number of years since 2000. So in 2000 t would be 0. So we need to find population in 2000. That means we have to find t of 0. That would be 95.2 divided by 1 plus 1.8 raised to the power negative 0.018 times 0. 95.2 divided by 1 plus 0.8. E raised to power anything 0 is just 1. So we have, use your calculators, 95.2 divided by, this is 2.8, 34. So initial population in California in year 2000 is 34 million. So all of these answers are in millions here. Use this function to determine the time required for the population of California to double its value from 2000. So the question says, find the time when population is double the time we have in 2000. So double of that is 68 million. Population function is 95.2 divided by 1.8 raised to power negative 0.018 times t is given to be 68. We need to figure out time. So this becomes a equation. I can use cross multiplication like this. So 95.2 would be equal to 68 times 1 plus, so we can divide both sides by 68. 95.2 divided by 68 is 1.4. So we have 1.4 is equal to 1 plus 1.8 times e raised to the power negative 0.018 times t. Our goal is to find t. So we can subtract 1 on both sides. We will have 0.4 is equal to 1.8 times. We can divide by 1.8 on both sides. We have e raised to the power negative. We need to find t. So what will we do? We will take natural log on both sides. Natural log and e cancel each other. T is equal to natural log of divided by negative 83.5. So before, remember, it was 75 years. Now we are saying in 83.5 years, population of California will double itself according to this logical growth model. What is the limiting value of population of California under this model? So the limiting value comes up to be this number C. In this case, C is 95.2. We can actually also check the graph of this function. I want to show you, if you write this function in the testmos.com, I'm going to show you the graph of this. So I type this function, and if you notice, I don't see much in the graph. So I can change the window or zoom in, zoom out, zoom out. So here is my graph. So you see, it is an exponential function. It starts growing, and then after a stage, it keeps, let's zoom out more, it is stabilized. What is that? For that, I want to show you that if I draw this horizontal line, that is the horizontal asymptote of this function. So that means at the maximum, the population will grow to 95.2 million. So that is the answer to this. The limiting value of population of California, according to this function, is equal to 95.2 million. You can see it by graph, or if you compare this function and see the graph here, the C is your value, and in this function C was 95.2.